Okay, problem number 1. What are we doing here? Just say it. Go. Find the antiderivative, sub and solve. Find the antiderivative, sub and solve. Are we together? Does anybody have a question beyond that on problem number 1? Yes or no? Yes or no? Okay, no. Number 2. Yesterday, kids knew product rule. I was very proud of them. Did you know the product rule? Heads up, look up here. So we have the first function. Whoop, let me change the pen. Change this to blue. So we have the first function times the derivative of the second. What rule? Go. Chain rule. So we have 1/2 of 2x minus 3 to the times. Okay, so first derivative second plus second. Are we okay? Derivative of the first. Okay, then you look at there and you look at there and you look at there and you go, wait, I'm doing something wrong. Oh, no, I'm not. I got to clean it up. So 2 divides out with 2 and I get x over square root of 2x minus 3. Agreed? Plus square root of 2x minus 3. And look. Wait a minute, I'm doing something wrong. No, I see what they did. They took 2 fractions and added them together to make 1 fraction. How do you add fractions? Thank you. You get a what? Common denominator. What's the common denominator here? Square root of 2x minus 3. We call this algebra. We call it 4th grade math. So this already has a denominator of 2 square root of 2x minus 3, so nothing changes. This one doesn't, so I have to multiply the bottom by the square root of 2x minus 3 and the top by the square root of 2x minus 3, and I get, 2x minus 3 without the radical. Yes or no? Combine like terms, 1x and 2x gives me 3x. Is it minus 3? Yes, and I choose A. Are we okay? In problem number 3, they tell you half of the answer, don't they? Yeah. The concept here is that the student must recognize that they have to use integral properties to take this thing apart and rewrite it as the integral from a to b of f of x dx plus the integral from a to b of 5 dx. We know the answer to this because they gave this the answer. What's the answer? A plus 2b. They gave us that answer. Are we in agreement? When we find the antiderivative of 5, we get 5x evaluated from a to b, so we get 5b minus 5a. We combine like terms. A minus 5a is negative 4a, and 2b plus 5b is 7b, and the answer is C. Questions, doubts, fears, or concerns? Are you okay? What number are we on? If the page will ever turn. There we go. That's like a soap opera. If the page will turn. All right. Number 4. When you find the derivative, and this is a very simple problem, when you find the derivative of 1 over x, what do you get? Good for stopping. Oh, wait a minute. No. The integration of 1 over x is ln of the absolute value of x. The derivative of 1 over x, you change 1 over x into x to the negative 1, and you use the power rule, and then you substitute and choose your answer. Number 5, this was a doozy at lunch yesterday. It was a doozy not because of calculus, it was a doozy because of algebra. You better believe it. So here we go. Give me your second derivative, please. Read it to me. 36 x squared, 96x plus 48. Okay, did everybody understand why we're going to the second derivative? All about me sheet. Second derivative to get concavity. We got to set that equal to 0, but ooh, look at those big numbers. What can we factor out? Or, yeah, you're right, 12. So that leaves me with 3x squared minus 8x plus 4. All factoring. Agreed? Factoring. Now, when I look at the answers, I already know that A and B can't be answers. I know they cannot be solutions. Why do I know that A and B can't be solutions? Just by looking at what I have here. There's no factor of what? There's no factor of just plain x. So the only way I could get a 0 as a root is if one of the factors is x, yes? So that's out and out just by looking at my second derivative. Are you okay? Now, the next thing that happens is kids say to me, I can't factor that, and then I'm embarrassed for them. Oh, I'm embarrassed for them, but I say, hey, you could use the answers to help you. You can see from here that the critical numbers are either negative 2/3 and negative 2 or positive 2/3 and positive 2. And I said to the kids, I think you're smart enough to realize that since that's plus, these two have to be the same, so you have to have a minus minus. Yes or no? And if it's a minus minus, then you know that this one's out. Because if you have x minus 2 set equal to 0, you get x equal to positive 2. Are we together? Look, I didn't even factor, and I know the answer is between these two right here. Are you okay? I take 2/3 and 2, put them on a number line, pick some values, make some decisions, and move on about business. Look at that. I did the problem without even really factoring, even though I know you should and could be able to do that. The next things that children said yesterday is, Mr. Jernigan, what do I do on number 6? Well, you have two tools. The two tools are normal and use sub. The fact that people said, Mr. Jernigan, makes me think probably not normal. So what's the only other choice? Use substitution. And when you have e to a power, if it's just e to the x, we're all happy. But if when you have e to another power, u is the power. So you get u equal to t over 2, so du, go. Come on. 1/2 dt. And look, this problem already has a half in it. Agreed? So when we substitute, we get the integration of e to the u, our favorite function ever. And when you integrate e to the u, you get e to the u, and you resubstitute back. So you get e to the t over 2 plus c, which is c. Are you okay? Okay, and problem number 7, what rule? 7. What rule? Chain rule, a little bit of trig going on in there, right? And the first thing I know a lot of kids did was to rewrite this as cosine of x cubed quantity squared. Agreed? And then you were like, wait a minute, I'm going to stop here because I remember, what happened? Come on, get out of here, cancel. All right. So you do 1, 2, 3. Anybody remember me ever numbering things like that? So we start with the outside. The derivative, or how we're going to deal with the power, is using the power rule. So we have 2 cosine of 3x. That takes care of number 1. Oops, where did I get that from? X cubed. Thank you. Okay, that takes care of number 1. What's number 2? Cosine. What's the derivative of cosine? Negative sine of the angle. And number 3 is the derivative of the angle, which is 3x squared times 2 is 6x squared. Are we in agreement? Do we understand? Okay, so really no big challenges on this particular test. You should be excited by that. To know that, oh, look, you can do this. That's exactly what I was getting ready to say. You can do this. Just get on the bus. Let's move forward. You can do it. Ooh, I wonder what other surprises lie ahead. Problem number 8. They give you a velocity graph, and they ask you, when does the bug change directions? What are you looking for on a velocity graph? Velocity changes sign. And when does the velocity change sign? At 6. So ching ching, we're racking up points here. Keyword in number 9. Keywords, total, and the most key of the words is distance, which tells me to find all of this area geometrically, and then take this area geometrically and make it positive, and take this area and add it to this area positive and get an answer of whatever the answer is. Yes? Number 10, the kid says, equation of a line. What does the kid write down on their paper? Yes, y minus y1 is equal to m times x minus x1. What are they giving me? They give me x, so I can at least go that far. Darn, I can't eliminate any of the answers, can I? Because they all have that in them. I have to go and find my own y value by pre-cal, yes? Cosine of 2 times pi over 4. 2 times pi over 4 is pi over 2. The x value at pi over 2 is 0. Well, that makes things nice, so I can get rid of that and just make it y. Agreed? Now I need a slope, so to get slope I need a derivative. The derivative of cosine is negative sine of the angle times the derivative of the angle. Then I put in pi over 4. 2 times pi over 4 is pi over 2. Look at me. Pi over 2. The sine of pi over 2. The y value of pi over 2. Y value of pi over 2 is 1. 1 times negative 2 is negative 2. And I choose the answer. Yes or no? How are you doing? Questions? Okay, turn the page. All right, number 11. Wow, this is such a nice test. They give me a derivative, agreed? And then I interpret the derivative, yes? Well, first of all, if this is a derivative and I go backwards, the answer has to be I have a quadratic. The anti-differentiation would be a cubic. So he's out and he's out. Agreed? The next thing I notice is that the derivative is 0 here and here. But on this graph right here, the derivative is 0 at -1 and 1. So he's out. Yep. The next thing I notice is that in this region, the derivative is what kind of number? Negative. Therefore, I'm looking for a graph that is decreasing. So the answer has to be E. Questions? Oh! The flying monkeys are back. Wow, not only can you do this, you have no choice. You must do this, or the flying monkeys will come and take you away. Hopefully no one in our listening audience was scared by that. Number 13, we're trying to figure out where an original function is decreasing. They give us the first derivative, and in this first derivative, the first derivative of this function is always positive, so the denominator is ruling the roost, yes? I want an outcome of what kind of number? I want a negative outcome, which means I need the denominator to be negative, which means I need to figure out which numbers make x minus 2 negative and which kind of numbers make x minus 2 negative. Numbers to the left or less than. Yep. Did I skip 12? Did I not? Why? Why did I skip 12? Why wouldn't it turn back? Did I just not pull the page down? Oh, yeah, 12, that easy one. All right, here we go. Kids wanted to freak out about this because they had to, stop and think. Wait, I haven't had to think about any problems. Wait, dang. All right. They give me a function, and they tell me, do you know what a parabola is? Okay, it looks like that. Agreed? And I have a tangent line, but I don't know what the tangent line is, correct? But I have a line that's tangent to that curve somewhere. That's what I'm trying to figure out. Where is it tangent? What do I know about my tangent line? Parallel to this line. Then I have to go parallel lines. Oh, okay, it's a slope connection. A slope connection. What do you think I need to figure out about this line? The slope. What's the slope of that line? The slope of that line is 1/2. Guess what? I'm done with that line. I'm done with it. That's all I needed. I needed the slope of that line. I needed the slope of that line to get the slope of my line. My line is a tangent line, which means that somewhere on my curve, the derivative is 1/2. Somewhere on my curve, the derivative is 1/2 because I have a tangent line whose slope is 1/2, yes? So I need to take my derivative, which is x, and set it equal to my slope. Oh my gosh, and the answer falls out. At x equal to 1/2, I have a tangent line whose slope is 1/2, and I need the y value. Where do I get it? 1/2 squared is a fourth times a half is an eighth. So I get b. Look, I'll show you what's going on. Go over a half and up an eighth. Let's say it's about there. All that's saying is that this tangent line, or line tangent to my curve, is parallel to that line that I crossed out. Got it? Got it? Bo, what are you doing? Ask me. I'm way smarter. No offense, but I am. Ask me. Try it. Okay. Number 14. I'll trust you on that one. Number 14. Here's another one. Oh, I have to think a little bit. It's not fair. Oh, wait a minute. No, you don't. They tell you you have a differentiable function. They give you a point. 3, 2. They give you a slope. 5. What is that? What does that make you want to do? It makes you want to write down a line, correct? Now I'm going to go with y equal, no I'm not. I'm going to go with y minus 2 is equal to 5 times x minus 3. Did I lose anybody? Okay, because they do say if the tangent line, well, there's a line, so that may be really. And what do they want me to do with my tangent line? Approximate a 0. Remember local linearity? And we would make a tangent line under a curve, and we said you can use the tangent line to approximate y values that are really, really close. That's all they're asking us to do. But see, they tell you what to do. Now, you have to know what a 0 is. What is a 0 of a function? It's where the graph does what? Come on, I think you can do it. Crosses the x-axis, and if it crosses the x-axis, the y value is 0. So all they're really telling me to do is take my line, plug in 0 for y, solve for x, and find out, on the original curve, there's a 0 at approximately whatever it turns out to be. Yes, no, maybe so? Okay. Dang, this is bothering my neck. Number 15. Where are we? 15? Limits. What's the left limit here? Left limit. We are approaching a y value. Can there be a limit there? Yeah, approaching. Remember, that's how we started our year. As we approach from the left, the y value we're getting closer to is 2. From the right, the limit overall. So there is a limit. Is there a limit here? No, because the left limit is 2. There's a left limit and there's a right limit of, but there's no limit overall because they do not agree. So I think the answer is B, don't you? Moving on. Some of you should be like, I think I can get 100 on part of this test. The area of the region. How do you find area? Top minus bottom. You draw a picture, x squared plus 1. You put a 5 on it. You find the point of intersection. Yes, no? How do you find the point of intersection? Plug in. Yeah, set them equal. Same thing. Plug in 5. Do the work. And then you're going to top minus bottom. So you'll have bound. What's the top curve? 5 minus. You know what some people messed up on? Some people messed up because they didn't put a parenthesis around x squared plus 1. They knew what they were doing. They found the bounds. Everything was great. But because they didn't put parentheses around x squared plus 1 to distribute it to the 1 in the back, over. You got to be careful. Number 17. You might have had to look it up. And if you looked it up, you probably almost found the exact problem in your packet on implicit differentiation. Are you ready or not? What's the derivative of x squared? 2x. You're very smart. What's the derivative of y squared? 2y. dy dx. What's the derivative of 25? 0. When you solve for dy dx, what do you get? Is it negative x over y? First derivative. Easy or hard? How do you find second derivative? Quotient rule. So we have down d up minus up d down, yes, over down. Now, at this point, it's up to the child whether or not the child wants to clean this up. But since we're only using this to find the second derivative at 4, 3, I'm going to plug a 3 in for y, a 4 in for x, and then over here, see what's going to happen? I'm going to plug in the 4 and the 3 over here, take it over here, do the arithmetic, plug in a 3, do the arithmetic, add, subtract, multiply, divide, whatever I need to do, and choose my answer. Questions? Does that mean you understand, or does that mean you're so lost you don't even know where to begin? It's like so quiet. Okay, that's good. That's the question kind of thing I like. May I get rid of that? Thank you. All right, let's look at number 18. Is that normal or U sub? U sub. What branch of math must you know in order to unlock the teeny tiny itty bitty little secret? You must know that 1 over cosine is secant. So what's U? U is equal to tangent x. Du is equal to secant. Did you say secant squared dx? And so we already just said that this problem really says e to the tangent x times secant squared x dx. So we get e to the u du. Yes. When you integrate e to the u du, it's our favorite function of all. You get e to the u. I replace the tangent x back in there, and I evaluate it from 0 to pi. Look how nice they are. Pi over 4 is our favorite tangent angle. What's the tangent of pi over 4? 1. And then I have to do it's e to the 1. E to the 1. E to the 1, which is e. Then I have to do tangent of 0, which is 0. And e to the 0 is 1. So we get e minus 1. Yes? Now, the first one that we've encountered that made us have to scratch our head maybe a little bit is number 19. And what made us scratch our head a little bit is not the fact, we all know that the derivative of ln of u is, that didn't bother anybody. So everybody automatically said, you know what, it's either this, this, or this. I think every person was able, but what was bothering you was like, what do you do with that absolute value? That's what's making me nervous. Well, on the real AP test, you at least have it knocked down to a 33 1/3% chance of getting it right by elimination. Yes? And sometimes that might be where you have to go. You might just be like, I'm not sure. Well, the correct answer, as you know from the answer key, is letter D. Now, did anybody choose A? Okay, let me talk to you about why A is not. I understand why you did. Let me talk to you about why A is not the answer. You ready? Normally when we have an ln graph, are you ready? Normally when we have an ln graph, now this is not just the basic ln graph, but an ln graph only gets graphed on the right-hand side. Well, the fact that we're taking absolute values means that we actually can have graph on the left-hand side. Because if you pick a number like well, they're all going to be positive anyway. Does -5 have an output? Yeah, because -5 squared is 25 minus 1 is 24, and there is an ln of 24. So the negative numbers in this case, because we're absolute valuing squaring, there are outputs on the left-hand side, yes? Now the graph is something like that. Well, all the slopes over here are what kind of numbers? They're all negative numbers, and if I pick A, I'm only going to get what kind of slopes? Positive, so I'm leaving out half of the slopes. Bottom line, if you're like, I don't get it, 33 1/3% chance, I'm willing to go for it, okay? All right? What? Well, there's no never. You have to consider case by case. Look what you're going to get. Yay, 5. That's your score. It's like a future prediction. Number 20, average value. Why do we love average value? It's a formula. What got in your way? Pre-calculus. So you said 1 over 5 minus -3 from -3 to 5 of cosine of x. Yes or no? And then you said that's 1 over 8, and you were like, boom, boom, boom. Uh-oh, I crossed off. Oh, yeah. So now I'm down to 50-50. Even if I can't figure out why my answer won't turn into their answer, I'm 50-50. Agreed? It's all pre-cal. When you find the antiderivative of cosine, what do you get? Oh, no, they didn't. What's the antiderivative of cosine? Sine from -3 to 5. So you get 1/8 of sine of 5 minus sine of -3. Yes? And then you're looking at your work and looking at their work and wondering why none of their answers have a -3 in them. Correct? Well, then one goes to pre-cal. And they're going, you know what, I bet they did. They're using, when I think back to pre-cal, and you really need to understand this, it's not that hard. This is an angle of -3 radians, because everything in calculus is in radians. Now, this is pi, which is 3.14. So -3 radians is like over here. Well, +3 radians then is over here. In this quadrant, signs are negative, and in this quadrant, signs are positive. Wait. Are they saying that the sine of -3 is the opposite of the sine of +3? Yes, that's exactly what they're doing. Instead of using sine of -3, they're replacing sine of -3 with the opposite of the sine of 3. So if I do that, I'll have 1/8 of the sine of 5 minus negative plus the sine of 3, which is E. Got it? Just pre-cal. That's all it is. Not the calculus part, the pre-cal. Now, what'd you pick for 21 and why? Limit does not exist because the ln of 1 is 0. Can you divide by 0? No. Number 22, we're trying to figure out where a function is increasing. So what do? Find the first derivative, set it equal to 0. Now, you may have been a little bit nervous about that. You get x first derivative of the second negative e to the negative x plus the second e to the negative x times the derivative of the first, 2x minus 3, yes? Now, you do have to be able to factor here, ladies and gentlemen. What do you factor out? I don't care if you factor out. So you get e to the x. That leaves you with negative x. You're right. That leaves you with x squared. What? Okay, I'm just trying to hurry. That's my fault. So you get x squared left over. You get 2x left over. And you get minus 3 left over. Yes? You factor that. Get your critical numbers. Can e to a power ever be 0? E to a power can never be 0. So you don't get a critical number out of that. Agreed? You get your critical numbers out of this by factoring. You can kind of get a hint as to what they are. You make a number line and make some decisions. Yes or no? Okay, number 23. Oh my Lord, how many times did we revolve y equals square root of x? How many times? A gazillion. What? Oh, that's because I didn't pull my negative. You're right. So if I pull the negative out, that would be x squared minus 2x minus 3. No, it's not. It's going to be minus. I know I'm right. Okay. I'm just being fast. That's why I'm making silly mistakes. So thank you for catching them, and thank you for not letting me get away with them. What are we revolving around? I'm revolving. I'm revolving. What are we revolving around? Y-axis. When you revolve around the y-axis, you're in terms of y. That means your bounds are in terms of y. That means your radius is in terms of y. That means you have dy. Everything is in terms of y. Did you get it right? Because this is very recent stuff. What number are we on? 24. God dang, we're almost done. We're not doing 25, right? Oh my, Riemann sums. This is a right Riemann sum. This is the width. These are the heights. Take notes. Red pennant. You know, some of you didn't know. Some of you looked it up. Some of you didn't. Some of you looked it up and you're still like, oh my gosh, I don't know what I'm doing. How do you find the width, common width? I got one person with me. B minus A over N. So I know that there are 50 subintervals. Agreed? There are 50 subintervals, and I know that B minus A is equal to 1. Agreement? Now, I think everybody was smart enough to figure out that the function, what's changing is the 1, the 2, the 3, the 5, etc. So the x goes in place of that. Yeah? I think you were smart enough to figure out that the function that we're dealing with here is x over 50. Yes or no? So we can eliminate this one, we can eliminate this one, and we can eliminate this one. Feedback? Feedback? Now, this is the last right endpoint. The last right endpoint is 50 over 50, which is 1. Yes? Yeah. What mistake am I making here? Oh, because we're moving by a 50th and a 50th and a 50th and a 50th and a 50th. You are absolutely right. Thank you. Let's rehash that. All right, are you ready to back up? Okay, so the function, if we're moving 1/50th, we start it on the number line at 0, we move a 50th. That's the x value of the first right endpoint. And we're taking the square root of the first right endpoint. Then we move to the second right endpoint, which would be 2/50ths. Then we're taking the square root of 2/50ths, so you are correct that the function is not the square root of x over 50. In fact, it is the square root of x. And since this is the last right endpoint, 50 over 50 is 1, so that tells me the b value is 1, the a value had to be 0, and that's why we get b. Thank you for not letting me go so fast that I mess up problems. Questions? Okay, stop.